Alright, ladies and gentlemen, time for a little lesson. Just kind of explaining the exponential function parameters. This doesn't really have entirely new things, but we're going to go over a few examples just so you can kind of get a reminder and see how these things work and how to answer some of the questions. So we're not going to look at all the problems, just going to look at a few of them. Let's start by looking at problem 2. It says the amount of money Kate has in her I really should go to college savings account can be modeled by the function s of x equals 2500 1 times 1.06 cx power. I think on yours it just says s or y or something. Anyway, so it asks you a couple questions about it. It gives you the function, it gives you the equation and you answer some questions. So it's asking what's the starting amount of money in the account. To figure that out, you had to remember our formula. For that, it's a times 1 plus or minus your rate as a decimal to the x power. Your starting amount is this guy here, and so we look at our equation, find what number's in that spot, and it's just 2,500, and so that is the starting amount in the account. We'll even put a little dollar symbol on it, $2,500. And the next one is asking what is the percent growth. To answer that question, again, we're going to look at our little formula here, but we're going to look at what's inside. The percent growth is this number, but here it's the simplified version of it. And so you have to think, well, what number got added to 1 to make 1.06? And so you can take 1.06 and subtract 1.0 and figure out that it's 0.06. Well, that is the growth, that's percent growth, but it's as a decimal, so we're going to convert to a percent, just times it by 100, and that gives you the percent growth. It's going to be 6%. If you're kind of fluent with converting decimals to percents, you might be able to see that 1.06 is just 106%, which is, well, 6% more than 100, so you can kind of jump straight to your answer there and realize that 1.06 is 106%, which is 6% more than 100. So that's kind of how you answer these sorts of questions. Percent growth, percent decay is finding out what the R value is. How is it different than just plain 1? Let's go to problem 3. You got a 42 kilogram chunk of uranium, which is slowly being depleted. The amount of uranium each year can be modeled by the function here, or modeled by the equation here. And this might just say U equals on your paper, or just Y equals. Both good. We're going to learn later kind of what this notation means. Anyway, first question here is, what is the decay rate? We just went over that. You need to figure out how this is different from 1 and convert that to a percent. So pause the video, go ahead and do that and figure it out. Did you pause? Did you figure it out? Figure it out. If you got 2%, hooray, you win! Yeah, this right here is, well, 0.98. So if you take 0.98 and subtract 1, you're going to get negative 0.02, which, if you want to figure out what the percent is, you can just times by 100, and that's going to give you negative 2%. And the reason it's negative is because it's decaying, and so we're gonna throw off that negative there. And it's a 2% decay, or it's losing 2% each year. So there you go, 2% decay rate. Now we interpret what the 42 means. Well, here's our 42. Again, look at the formula, or the formula, and figure out where that number lies and what that number represents. Again, pause the video, figure it out, write it down. Alright, if you figured out that it represents the starting amount, awesome. I do want you to explain what it means in the context, though. This 42 is connected to this 42. It's the same number, it's representing the same thing. It is the starting amount of uranium. I do want you to add in the detail of what is 42. So this is 42 kilograms of uranium, and we'll put parentheses kilograms there. So there's that. So a couple of problems where we kind of interpret what the parts, you need to know what decay rate means and percent growth. That's just looking at what's the percent change there. So we're going to jump to another one. Let's jump to 8. Professor Evil is filling up a silo with toxic sludge. The height in feet is modeled by this little equation here as function. It might just say S equals. And it's the height each minute can be modeled with the equation. If it takes 5 minutes to fill the silo, how tall it is. So we haven't really done this a whole lot in class, but this X represents number of minutes. And it's asking us, well, how tall is it in 5 minutes? So we're going to take 5 and we're going to put it in the exponent here for X. So you can use a calculator to help you do that. You just do 2.75, parenthesis 1.9. And then you have to get the exponent up there. To do that, you have to find the button that looks like this. It's almost like an up arrow. It's right above the divide button on your calculator. If you push that, that is the exponent button, and it'll put the cursor up here, and you can put in 5. And then you just push equal, and it gives you a number, and that'll be your answer. I don't have my calculator on me right now, so I'm just going to leave it to you to do that. Just put it to the 5th power. And the next question here, what is the height of the sledge when X is 0? So that's at 0 minutes. Really similar to the last part, you're going to put 0 in this X location and compute it. So go ahead, pause, figure that out, and write it down. Hopefully you got 2.75 because anything 0 powers 1, which might be a property of exponents you might remember. But yeah, you get 2.75, and that's in feet because this whole thing's in feet. So there you go. Just use your calculator to help you compute things. And we got one more problem that we're going to look at, just kind of give you a feel for things. So we're going to go to problem 17. You get a bunch of money, and you get $10,000 because someone passed away, and they were very generous with you. You decide to throw it into a savings account, which gives 4% growth, right? If you have a savings account, they're giving you that money, so they're adding 4% each year. And you're going to put in $9,000. So I want you to write out the equation. Y equals, pause the video, try it out, and then come back and check. We've been practicing this a little bit with our previous lesson here. So give it a shot. And so let's check this out. You should have 9,000 here, not 10,000, because you're putting in 9,000 like it says here. And you want to start with 1, and since it is growing, you're going to add 4% as a decimal. 4% as a decimal is 4 divided by 100, 0.04. So we're going to add 0.04, and it's going to be to the x power, just any old x power there. And now we're going to combine these together, and you'll get y is 9,000 times 1.04 to the x power, and there you go. I'm okay if you skip writing this out and just jump straight to that. We're getting used to that. If you add 4%, that's 0.04. You add that to 1, so you get 1.04. Or you can think of it as start with 100%, add on 4%. That's a bad 4. And now you got 104%, which you can then just divide by 100 and get the decimal, which is 1.04, which is this number. So it's kind of another route you could take to figure out what you're timesing by there. So there you go, kind of looking at some of the examples on your assignment, getting a feel for what the questions are like and how to answer them. So good luck. May the force be with you.